When I think about health, when I think about diets and lifestyles, I'm always trying to think about what's the unifying philosophy? What's the unifying components? Why is it that some of my patients can go whole food plant-based and seemingly thrive, whereas others go low carbohydrate whole food based and are also thriving? And I've always felt that these dietary wars are a little bit problematic because from clinical practice, I've seen people do seemingly quite different things and still do well. So what is the unifying feature? Okay, well, all the diets that work well in the short term and long term, I think help lower inflammation, right? That I think pulls them all together. All diets that tend to do well in the short term and long term, I think help us be metabolically flexible. And I know you've written about metabolic flexibility. We have time, we'll talk about it today. But then I thought I'd never thought about mitochondrial uncoupling until your work with unlocking the keto code, where I thought, wow, if this is true, this is another unifying concept that shows why potentially some quite different diets and lifestyles still can harness and encourage really good health outcomes. Now, since that has come out, Dr. Gundry, has there been any pushback? Like, is mitochondrial uncoupling well accepted science, or is it still a hypothesis that you're trying to put forward?
No, it's not my hypothesis. Mitochondrial uncoupling is very well proven science. We know there are five mitochondrial uncoupling proteins, UPCs, that were actually discovered in the 1970s. And these uncoupling proteins actually are emergency exits out of the electron transport chain. And in the book, I use the example of the Mito Club, where it's the hottest club in town and things can get pretty rowdy. And people are trying to couple when they go to these clubs. And unfortunately, things can get so rowdy that you've got to disperse the heat and the energy. And it's actually what happens is, protons are supposed to couple with oxygen and exit through a one-way turnstile and generate ATP. And that process of the electron transport chain is really nasty, generating reactive oxygen species. And so you need to have literally pop-offs, like a pressure cooker. If a pressure cooker gets too high, you've got to release that pressure. So you have a pop-off valve. And what was discovered is that mitochondria have these pop-off valves, and these uncoupling proteins, these emergency exits, are manipulable. They are controllable by chemical signals, by, for instance, ketones uncouple mitochondria. They open these trapdoors. Polyphenols open these trapdoors. And my favorite example, which I talk about a lot, is this compound that was discovered after World War II called 2,4-dinitrophenol, DNP. And it's a fascinating story. Munition workers in France and Germany during World War I were noted to be profoundly skinny. And they were always running a temperature, and they were eating incessantly, but they were profoundly skinny. And it wasn't until after the 1920s when it was discovered that in the process of manufacturing gunpowder, there's a chemical called 2,4-dinitrophenol. Remember that word phenol. It will show up in polyphenols. And a couple of Stanford doctors said, hey, these guys were really skinny, and obviously this stuff makes you really skinny, and I think it's a weight loss drug. So they actually wrote over 100,000 prescriptions for 2,4-DNP to humans. Mm-hmm. And it was miraculous. At a normal dose, you would lose a pound a week. If you up the dose, you could lose up to 5 pounds per week. And it was a miracle, except the more you took, the higher your temperature went. You actually developed cataracts, and to the extreme, you died. Now, subsequently, when the FDA banned DNP in 1938, but subsequently it was discovered that DNP was the first discovered oral mitochondrial uncoupler. And that explains why they lost so much weight. And it also explains why they ran such high temperatures, because they were generating heat. Now, there's been a lot of interest in looking at precursors of DNP to see if you could control the side effects. And there's several companies that are really looking into this. But the long story short is we know from actual fact that phenols uncouple mitochondria. And so you go then, well, gosh, let's look at the spice trade. Let's look at polyphenol consuming populations. And you go, son of a gun. These things, were the original drugs. And that's why people paid. Nobody paid a lot of money to put black pepper on their steak. They paid a lot of money to get the uncoupling benefit of black pepper.
Yeah, it's so interesting to look at food through that lens. Of course, people can read the book and get all the detail on all the things that you recommend. We touched on intermittent fasting. There's a section on that. Fiber, as I said, prebiotics, postbiotics, polyphenols you mentioned. Just a quick summary of foods containing polyphenols for people.
Well, the fun thing, let me go back. So plants have mitochondria that are called chloroplasts. And plants use photons, which is equivalent to our oxygen. And photons from sunlight are extremely damaging to plant mitochondria, just like oxygen is actually extremely damaging to our mitochondria. But it can't live with it, can't live without it. So plants manufacture polyphenols in their leaves or in their fruit to protect the mitochondria from damage from sunlight and to repair that sunlight. And they actually uncouple chloroplasts. So now when we eat polyphenols, and best in the fall, we get to see all the polyphenols in the leaves of trees that we didn't see because they were covered up by the green. And as that green chlorophyll goes away, there's the polyphenols, all the yellows, oranges, reds, purples, all these magnificent colors. Those are the polyphenols. The problem with polyphenols are we absorb them incredibly poorly. But some of the exciting new evidence is that polyphenols are one of the favorite foods of our gut microbiome. Our microbiome just thinks polyphenols is sliced bread, and that's a poor analogy. But so they, in turn, make polyphenols absorbable, bioavailable. And so the benefit. So whenever you see a beautiful colored something, that's the polyphenols. And for instance, olive oils loaded with polyphenols, cacao, dark chocolate loaded with polyphenols, coffee loaded with polyphenols, tea loaded with polyphenols, and so on and so forth. Red wine has its benefit because not only the polyphenols in the grape skins and the seeds, but also a great amount of red wine is aged in oak wood barrels, and wood has polyphenols that are absorbed.
Yeah, thank you. In the context then of mitochondrial uncoupling, why is it that you're so passionate about recommending sheep and goats products?
So these blue zones are sheep herders, goat herders. And sheep and goats, first of all, a lot of people now have heard of medium chain triglycerides, MCT oil. And medium chain triglycerides are a fat that's unique in that they are absorbed directly through the wall of our gut rather than on chylomicrons, and that's a long story, but they go directly into our liver. And they're converted, for the most part, into ketones, regardless of what you're eating. So you could have I joke, a fresh fruit salad and have a tablespoon of MCT oil, and you will generate ketones despite eating a very high carbohydrate load, which is interesting. So it turns out that all of the various medium chain triglycerides are named after goat, capra. So there's caprylic acid, caprolic acid, capra, goat. Why? Because it turns out that goat and sheep, 30% of all the fat in goat and sheep milk are medium chain triglycerides. Cows don't really make a lot of medium chain triglycerides. Humans make a lot of medium chain triglycerides in our milk. Water buffalo have a lot of medium chain triglycerides. Turns out donkey milk actually has a lot of medium chain triglycerides. So isn't it interesting that these super long-lived blue zone, white zone people are sheep and goat herders, and that a lot of their diet is sheep yogurts and goat yogurts and kefirs and cheeses. And part of what I propose is these guys live a long time because they're uncoupling their mitochondria. Now, there's another fascinating globule in whole milk, regardless of the animal. That's a milk fat globule membrane. And it's a membrane that actually in animal milk surrounds the fat globules. It's only in fat. It's not in skim milk. That's removed. And it, in and of itself, and there's good papers, is a mitochondrial uncoupler. So isn't it interesting, for instance, getting back to that one paper, butter has a negative effect on angina. Butter doesn't have any of these, whereas cheese has these things. In fact, I'll give you a little heads up. Harvard researchers have determined, one assistant professor has determined that whole fat ice cream eating actually reduces the risk of diabetes. And that certainly goes against party line and conventional wisdom. Yet every which way you break it down, the same thing comes up. And it's actually because of the fat globule membranes in whole fat milks, and they're in cheeses.
Yeah, well, if we had more time, I'd love to explore that, because I'm certainly not recommending whole fat ice cream to my patients.
No, I'm not recommending that everybody have ice cream for diabetes.
I mean, in terms of what we have got general agreement on so far, fermented foods is something that's very good for us. Polyphenols, however we might get them, dark chocolate, tea, coffee, colorful vegetables, whatever it might be, good for us. Olive oil, really, really good for us for a variety of different reasons. You're making the case for goat's cheese and sheep's cheese and why specifically they may be beneficial for us. In terms of a food that you have become globally associated with, for potentially recommending that some of us, all of us, avoid, is lectins. Now, lectins are in a lot of different foods. As you said, you published The Plant Paradox 6 years ago. It blew up globally. It was controversial. How do you see the lectin situation now? What's your current view? Has it evolved? And also, the question I really want to understand from you is, do you recommend that everybody thinks about avoiding lectins, or is it more so for people who've got impaired gut microbiomes and potentially severe autoimmune disease, where you may see more of that benefit?
So about 80% of my practice now is autoimmune diseases. A lot of them have been kind of all over the United States, the world, looking for somebody to fix it. And they kind of end up in my office. every human, and I measure leaky gut tests on these people, on a lot of my patients, and every human being so far with an autoimmune disease has leaky gut, 100%. 99.5% of people with leaky gut have antibodies to wheat germ agglutinin, the various gluten molecules, and non-wheat proteins, as well as 70% of them have antibodies to corn. They cross-react with a gluten-like molecule in oats, barley, rye have gluten. And so I can say unequivocally that the vast majority of people, number one, have leaky gut for reasons I've gone into before, but they have antibodies against numerous lectin-containing foods. We also test them against antibodies to various lectins. And most people carry antibodies to one or more beans. Great number of people carry antibodies to the lectins in cucumbers, to tomatoes, to potatoes, to peppers. Interestingly, in the new book, I write about a new class of lectins that I did not want to go into in the plant paradox because I didn't want to be even more controversial. But there's a class of lectins called aquaporins, and we'll leave it at that. But spinach has an aquaporin. And some of my MS patients are big-time spinach eaters, and they carry an antibody to the spinach aquaporin. And when we take spinach away from them, that was the final thing that flipped things around. Now, having said all that, the exciting thing, the reason I do this, is if we follow these people 9 months to a year, and I publish this, these people, their antibodies against all of these components subside, disappear. They are gone. 100% of them lose these antibodies. And I've had people who have been gluten-free for 10 years still have antibodies to wheat germ agglutinin and gluten. When we take away the other lectin-containing foods from them, then they lose all these antibodies. And we can reintroduce these foods because we've sealed, and they're leaky gut seals. And I guess that's the point. And one of the things that I've tried to make people understand is that cultures of fermented foods have taken hulls off of grains from the beginning of agriculture because fermentation reduces lectins. And so does taking the hull off of things. And these people didn't know that that's why they were doing it, but they absolutely felt better.
Yeah, I really appreciate that. And you know, maybe I can persuade you to have a part 2 one day where we actually explore that a bit more, because I think it's a really, really interesting point. Again, it speaks to this theme throughout our conversation that context matters, what's going on with you at this current time. And, you know, Dr. Fasano's theory on autoimmune disease, which I really, really like, is that in order to have any autoimmune disease, you need 3 things: genetic susceptibility, some form of environmental stressor, whether it's food, pollution, stress, whatever it might be, and you need increased intestinal permeability, also known as leaky guts. If you've got those things and you have an active autoimmune disease, then it stands to reason that the diet you need at that point may be different from someone who's got an intact gut barrier, who doesn't have the genetics, who's actually feeling really good. So, you know, when we say, should someone avoid gluten or not avoid gluten? Well, it kind of depends. If you enjoyed that clip, here's another powerful clip that I think you are really going to enjoy.